Hello and welcome to Communicating Concentration. In particular, we're going to take a look at molar volume. The units for molar volume are moles per liter. Very important that the volume is always in liters. So most solutions are similar in that they are colorless. Some are colored, but they're definitely clear. And aqueous, remember aqueous just means dissolved in water. So there is no way of knowing by looking at them how much of the solute is present in the solution. The solute is the thing that is dissolved, and the solution or the solvent is what is doing the dissolving. Usually water. So to do quantitative analysis, or in other words, how can we tell how much is present? Numerical representation is needed. We need data points. So concentration is a ratio comparing the quantity of the solute to the quantity of the solution. In general, concentration, or C, of any solution can be expressed as your solute, again, the thing that's being dissolved, and the solvent. So salty water, the solute would be your NaCl, and your solvent would be water. And we'd say, okay, NaCl is dissolved in water, but then maybe we want to know how much of the NaCl is actually, like how many grams in however many liters or how many moles in the volume. So dilute is a relatively small quantity of solute per volume of solution. So dilute is an example here. If you take a look, there's very little solute particles compared to a concentrated solution where you have a lot of solute particles in the same volume of a liquid. Concentrated is a relatively large quantity of solute per volume of solution. If we take a molar or amount concentration is the amount of moles, and molar concentration is another word for the amount of moles in 1 liter. So amount concentration, also known as molar concentration in moles per liter, is the amount of moles of a solute per liter solution. This is the most common form of concentration used in chemistry, and we're going to be using it lots. So simple formula, C is equal to N over V. N is your number of moles, and your V is your solvent or your solution. It's usually water, but it's always measured in liters. So let's take a look at an example using a formula. A laboratory technician made a solution using 0.255 moles of sodium hydroxide. So let's break it down. We have 0.255 moles in sodium hydroxide in 1.50 liters of solution. Calculate the amount or the molar concentration of sodium hydroxide. So we use our formula C equals N over V. We simply plug in our number of moles and our volume. Our number of moles is 0.255 moles over 1.50 liters. Now it's already in liters, we don't have to convert. Sometimes you're given volume in milliliters. At that time you have to convert to liters. So we get an answer of 0.170 moles per liter. We can use a different one. If we don't want to use a formula, we can use a factor label method. And factor label method is telling you it's a conversion, right? It's a conversion saying that moles per liter can be articulated in 2 ways. Way A, you can say that there's 1 mole in 1 liter. Or B, we have 1 liter contains 1 mole. Depending on what you want to cancel out, we use those as a conversion factor. So let's take a look and break down the question. A sample of ammonia solution has a concentration of 11.5 moles per liter. Take a look. This is your conversion factor. So you can say that 11.5, there's 11.5 moles in 1 liter, or you can say that there's 1 liter has 11.5 moles. What chemical amount, this is number of moles, right? What chemical amount of ammonia is present in 3.5 liter bottle? So you need to start with this. You always start with the data that only has one unit. So you have your 3.5 liters here, right? Now you have to choose this or this, but you want to make sure that liters cancel out. So you definitely choose this one. Your liters are going to cancel out, and then you get your answer in moles. And all you're really doing is you're going 3.5 liters times 11.5 moles, and you get 40.25 moles, or moles per liter, I should say, as the question. A chemical analysis requires 2 liters of 0.150 moles per liter of silver nitrate. What mass, now we're looking for mass of silver nitrate, is required to prepare the solution? Okay, so let's take a look. So we have silver nitrate. This is our molar mass of silver nitrate. Why do we need molar mass? We need molar mass because we're looking for mass of silver nitrate. Okay, so we need to have the molar mass figured out of silver nitrate. Now what we're going to do is we're going to have to figure out the moles of silver nitrate and then convert them to the mass of silver nitrate. So we start with our volume, which is equal to 2 liters, and here is our concentration, 0.150 moles per liter. Okay, now what you need to do for here is you need to figure out, are you going to use 0.150 moles per liter, or are you going to say there's 1 liter in 0.150 moles? Because I have liters, I want to cancel out my liters. So of course I'm going to use this so that the liters cancel out. Now I get moles of silver nitrate, but I'm asked for the mass of silver nitrate. That's why we incorporate the molar mass. Make sure that the moles cancel out, and we just use our calculators. 2 times 0.150 times 169.88 is going to give you an answer 51.0 grams, and that's your mass of silver nitrate. So a student dissolves 5 grams of solid sodium carbonate. So now we have 5 grams of solid sodium carbonate to make 125 mils. Careful, careful, I have to change that to liters, of a solution. What is the concentration? Now we know that concentration, we have one of 2 ways. Concentration is equal number of moles over volume. You could chunk this out and find the number of moles and then divide it by your volume, or you can use your linear kind of equation thing. The only thing I need to add for sure is I need to make sure that I have my molar mass because I'm given grams. So now I'm going to show you one of 2 ways. I start off with 5 grams. I use my molar mass. This time my grams are on the bottom because I want my grams to cancel out. Then I'm going to be left with moles. Now here's the thing. If you use the linear equation type thing, it has to be 1 over 0.125 liters. Remember, we had to convert to liters, which is 0.125 liters, because molar concentration is moles per liter. So at this point here, you have to put 1 over the 0.125. Why? Because I don't want to get rid of moles, and it's not moles times liters. Like if I did this, 5.00 grams times 1 mole over 105.99 grams, I'm not going to go multiply by 0.125 liters. Because in this case here, the grams cancel out, but it's moles times liters, and I want moles over liters. So I have to go 1 over the 0.125 liters. Or I can just find that my answer of moles and then use my formula. Okay, put your answer here for number of moles and divide it by 0.125. Whatever works, works. It's all good. And that's it. So how to find moles? It's just your formula, C equals N over V. And I will post some practice and the key. Have a nice day.